All right, guys, chapter 12, we're starting geometry. You do need a protractor for this lesson. If you don't have one, you need to get one, okay? You have to have a protractor. So sorry if they're in your locker. Figure it out. I don't know. I don't know what else to tell you. But here we go. You will notice the notes for this chapter. I did not handwrite these out. I just took pictures of the textbook because there's just so many words and pictures and diagrams when we get into this stuff that it just was not going to make sense for me to kind of handwrite notes and then try to import pictures and diagrams and stuff like that. So I just took pictures of the text, whited out some stuff so we could still kind of have some fill in the blank kind of experience as we move through this. So first of all, what is geometry? Okay, some people say they love geometry, some people say they hate geometry. You all know how I feel about it. But regardless of how we feel about it, what is it? Okay, geometry is the study of points, lines, planes, and the figures they form. That is the basis of geometry, okay? The table below lists the three basic geometric figures. So this is the very bare bones beginning of geometry, okay? The first figure we have right here, okay, and it is labeled as A, okay? And that is a point. And we would call that point A. The symbol for that is just the letter A. A point shows an exact location in space and is represented by a dot. That's the definition of a point, okay? Our second figure, we have a line BC. The symbol for the line is a line with the arrowheads on both sides over the capital letters BC. A line is a set of points that extends infinitely in opposite directions. That is the key, that it extends infinitely in opposite directions. So the line goes forever both ways, okay? And we name it based on 2 points on the line, okay? So this is line BC. The third figure we have is this right here, and we call this plane ABC, and our symbol for that, we literally just write plane ABC again. There's not like a nice neat little symbol. A plane is a flat surface that extends infinitely in all directions, okay? In the symbol line BC, the arrowheads indicate that the line continues without end in both directions. The table below lists two basic geometric figures that are part of a line. So here we have something that looks very similar to a line. However, we have two endpoints at the end here. So this is a segment. Sometimes people call it a line segment. Both are correct. Segment or line segment is fine. And we would name it segment GH. Okay, the symbol for that is just a line without the little arrowheads and the points on the endpoints. Okay, so GH. A segment is a part of a line that consists of two endpoints and all the points in between them. So it doesn't end, it stops on both sides. It doesn't go on infinitely. Not that it doesn't end. It does end, and it does end at both endpoints. It does not extend infinitely like a line. Then we have this picture right here, where on one side we are extending infinitely towards the right. On the left-hand side, we have an endpoint named J, and then we have the point inside named K. This is a ray, and this is ray J, K. Not just kidding. Okay, it is ray JK. You're all shaking your heads at me right now. All right, it's been a long day. And our symbol for this is a segment with an arrow at one end, JK. Now, what I need you to notice is that we have the J lined up with the part of that symbol that has the end point, okay, because the J is the end point of that line, all right? This would be incorrect to name this ray right here, okay? So we're gonna do a line through that one. A ray is a part of a line that consists of one endpoint and it extends indefinitely in one direction through a second named point. Okay, example number 1 asks us to name all the possible points, lines, planes, segments, and rays in the figure using the letters X, Y, and Z. So what are our points? Well, we have a point here at X, a point here at Y, and a point here at Z. So our points, X, Y, Z. Okay, where are our lines? Well, I see one right here. I see another right here. And I see another right here. So let's list all of those. We have line XY. We have line XZ. And we have line YZ. Okay? Then we're looking for any planes. Okay, any planes. This is a plane, a flat surface that extends indefinitely in all directions. Let me color this in. Okay, this is the plane. Okay, so we have plane X, Y, Z. Okay, segments, I'm going to change colors. Okay, where are our line segments? Well, we have a segment from X to Y, a segment from X to Z, and a segment from Y to Z. So we have X, Z, X, Y, and Y, Z. And then lastly, where are our rays? Well, we have one right here from X through Y. We have another one from X through Z, and we have another one from Y through Z. Okay, so we have XZ, XY, and whoops, YZ. Well, hopefully you already wrote that stuff down. And YZ. We also have rays from Z through X, from Y through X, and from Z through Y. So we have ZY, we have ZX, and we have, what's the last one? Oh, YX. Okay, so there we've labeled everything in example number 1. Okay, so for box skill check number 1, it says draw and label the following geometric figures. So we have number 1, that is a segment. So we would just draw a segment, A, B. All right. Number 2, that's a line. So we make sure we have the arrows at both ends, and we put the 2 points within the line to name the line MN. And then lastly, we have a ray where the end point is at X and Y is on the ray. Use the figures at the right for exercises 4 through 6. Name a line that passes through point A. So one line that passes through point A would be line CA right here. Okay, another line would be line AB. You could say BA also, doesn't matter. Okay, name a segment with endpoint B. Segment with endpoint B. Okay, we could do that. BA. We could also do this one. BC. You could do AB or CB as well. Okay, that would be fine. Name 2 rays with endpoint C. Here's a ray right here, and it clearly states CB. Oh, why did I do that? Clearly states CB, or clearly states that C is the endpoint, and this is also another ray with C at the endpoint. right? Fairly straightforward. Okay, now moving on to another definition, we're going to start talking about angles. So an angle is a geometric figure that is made up of two rays that have a common endpoint. The common endpoint is what we know of as the vertex. Each of the rays is a side of the angle. So over here, we have one ray, ray AB, and another ray, ray BC. Okay, so those are the two rays. They have a common endpoint at B. B would be the vertex of this angle, and ray BA and ray BC would be sides of the angle. Okay, we use this symbol for angle, and we can name this angle to the right three different ways. We can name it angle ABC, ABC, okay, angle ABC. We can name it angle CBA, okay, CBA, or we can simply name it angle B. We can name it after the vertex. You cannot name this angle A. You cannot name it angle C. You can name it after the vertex angle B. So this is a no, and this is a no, okay? The vertex is always in the middle of the name of the angles, ABC, CBA, okay? Angles are usually measured in degrees. To measure an angle with a protractor, follow these steps. We've done this before. We did this in 6th grade. You guys know how to use a protractor. Position the center point of the protractor on the vertex. So the center point of the protractor goes right here. Okay, align the 0 degree mark on the protractor with one side of the angle. Okay, and read the number of degrees to the other side of the angle on the protractor. Now, what you want to make sure that you are aware of is that your protractor is going to have two sets of numbers. Okay, two sets of numbers. Always a 90 right in the middle. Okay, and then over here we have a 0 and a 180. Okay, 0 and 180. And we go on the top here, increasing from 0 to 90. Okay, on the bottom though, we decrease from 180 to 90. And then from here, we go 90 to 180. And on the bottom, we go decrease 90 to 0. So you want to make sure when you are measuring an angle like this one, okay, this angle lines up with two different numerical measurements on the protractor. It lines up with 30 on the bottom, and it lines up with 150 on the top. You need to decide which is the accurate measurement, 30 or 90. Well, for this angle right here, this is going to be 30 degrees. How do I know that? Because it is smaller than 90, okay? It is an acute angle. It is smaller than 90 degrees. So I use the measurement that is smaller than 90, the 30 degrees, okay? So acute angles, measure of angle X is less than 90. So acute angles, they're tiny and cute. They're smaller than 90, okay? Right angles are exactly 90 degrees, and we indicate those with that little box. Okay, obtuse angles are obese. They are large. They are bigger than 90 degrees, smaller than 180. So they are in between 90 and 180 degrees. An angle that is exactly 180 degrees is what we call a straight angle. Okay? Find the measure of the following angles. So, measure of DAE. Here is DAE. We look, it lines up right with 50 degrees and with 130 degrees. This angle is smaller than 90 degrees, so that means it is 50 degrees. Measure of angle CAE. CAE. Right here, okay? That line goes through 125 and 55. 125 and 55, that is an obtuse angle. It is larger than 90 degrees, so that is going to be 125 degrees. Measure of angle BAC, BAC, right here, okay, that goes through 55 degrees and 125 degrees. It is smaller than 90 degrees, so that angle is 55 degrees. And lastly, measure of angle BAE is exactly 180 degrees. It is a straight line. Okay, so it's a straight angle 180 degrees. Okay, example number 3, name the following angles in the figure. All acute angles. So which angles do we have over here smaller than 90 degrees? Well, we have this angle right here, okay, which is angle FEH, acute, okay. We also have this smaller one right here, angle FEG. And then we have this one right here, angle GEH. Okay, any other acute angles? Yep, this one. Okay, that's angle EHG, or I'm just going to call it angle H. Okay, any other acute angles? Yep, right here, angle FGE or angle G. Okay, and that's all of them. Okay, there's the acute angles. Okay, name a right angle right here. Right angle, angle F. Okay, name an obtuse angle. Okay, an obtuse angle here, I'm given this measurement of angle G right here is 120 degrees. That obviously is larger than 90. So angle G is an obtuse angle. And a straight angle, and actually I'm going to give angle G a better name so that I don't get it confused with something else. Angle G, right here, I'm going to call it angle EGH. EGH. And then a straight angle, I have a straight angle right here, angle FGH. So that's my straight. And sorry, this one was my obtuse. Okay, you can write an equation to find the missing angle measure in the following example. Okay, if the measure of angle X or WYZ is equal to 23 degrees, write and solve an equation to find the measure of angle XYW. So how are we going to do that? Well, we are shown that this whole angle here, angle XYZ, angle XYZ is equal to 57 degrees. And we know that angle WYZ plus angle XYW are equal to angle XYZ. So those are equal to 57 degrees. Okay, we're given the measure of angle WYZ as 23 degrees. So 23 plus the measure of angle XYW is equal to 57 degrees. Subtract 23 from both sides, and the measure of angle XYW is equal to 34 degrees. Okay, find the measure of the following angles and classify as acute, right, or obtuse. I'm going to let you guys go ahead, grab your protractors, measure those angles out. And this small angle right here, this is smaller than 90 degrees, right? So we know this is an acute. The angle number 2 is greater than 90 degrees, but smaller than 180, so it is an obtuse. And when you measure angle number 3, it is in fact a right angle. So it is 90 degrees. Okay, when you check with your protractors, you should get 120 for this one, and you should get 39 for this one. Write an equation similar to the one in example 4 and use it to find the missing angle measure in the following figures. We are given the measure of this large angle, ABC, as 48 degrees. It contains within it angles ABD and angles DBC. So angle DBC plus angle ABC D is equal to angle ABC, the measure of angle ABC. So plug in what we do have. Okay, we have DBC, 33 degrees. We do not have the measure of angle ABD, so I'm just going to call that X. We do have the measure of angle ABC, that is 48 degrees. Subtract 33, and X is equal to 15 degrees. Okay, let's come over here. We have the measure of angle PQR as 136 degrees, and the measure of angle PQR is equal to the measure of angle PQS plus the measure of angle SQR. Plug in what we have, okay? PQS, we don't know, so that's X. We know SQR is 39, and that's equal to 136. Subtract 39 from both sides, and the measure of angle PQS is 97 degrees. Okay, that's this lesson.